in on these YouTube videos?
Non-rigid transformation. So the last ones they would be rigid, meaning the shape, you just kind of pick the graph up and move it. The shape doesn't change at all. Now the non-rigid is talking about, the U might get kind of wider or it might get real skinny. So this is absolute value. What shape does absolute value have? V. And with x minus 1 inside the absolute value, it's going to do what?
Right. 1.
To the right, 1. Now, we don't talk about slope except with linears, right?
Yeah.
But with the absolute value graph, I do refer to slope when you talk about the line, and normal V-shaped graphs or absolute value have a slope of 1 in my head, meaning I move over 1, up 1, over 1, up 1. It's kind of a 45-degree angle line. So as you do this, you could go to the left 1, up 1, to the left 1, up 1, to the right 1, up 1, to the right 1, up 1. No. But you just want to have, pay attention to it, because what's happening now is they're going to change the slope, if you will, and you want to catch that. So when I put a 3 out in front, what happens? You still have your x minus 1 graph.
Did it expand?
But every output now, so you're going to calculate, you plug in a number for x, you're going to get an output from absolute value, and then what do? Multiply by 3. So every one of these outputs that you have on the purple graph are going to go up 3. So you're still to the right 1, but now when you move to the left 1, you go up 3. When you move to the right 1, you go up 3. And so the issue with this one is, depending on what textbook you work with, some people call that a vertical stretch. And they call it a vertical stretch because it's like grabbing the graph and pulling it upwards, right? Some people call it, in textbooks, horizontal compression. It's like putting it in between and squeezing it together, and it smooshes it up. Which smooshes is actually the correct mathematical. Right. What happens with the 1/3 then? Same graph shifted to the right, but look at the purple graph and now multiply every output by 1/3. So you go over here, and instead of going up, you only go up 1/3. Then you move over again, and instead of going, you only go up 1/3. And so that one, yeah, you go over 3, up 1. Over 3, up 1. And so most people talk about, it gets wider. Those are non-rigid transformations. So now we could throw those on top of it. U-shaped graphs, Then you want to be a little bit more careful about what shape you draw. Because if you have to demonstrate, that's getting wider, make sure you're doing it. Okay. I'm going to give you a little bit of time again, so I will pause it. You'll work. Here's the idea. Try to look at these and write your own equation for them. Be careful, try to figure out, are they doing a non-rigid transformation? In other words, is there some sort of multiplier in the problem? If not, just write out the function. So you should look at this, like if this were an exam, you look at it and you already know what the common function is. You should recognize the shape of the graph. Then, did we move it up or down, left or right? Okay, so do that, write your 4 equations, then we'll put them on the board and we'll check it. Obviously, the first one is a linear. So we're talking about the y equals x is your common function. Now, don't say anything to your neighbor. Don't look at them when I write it up here. Your 2 choices are, 1, move this 1, 2, 3, 4, 5 to the right. So you either did x minus 5, or you might have gone 1, 2, 3, 4, 5 down. So we need to figure out who's right and who's wrong. How many think this was a graph shifted to the right 5? Raise your hand. How many said it's a graph shifted down 5? Raise your hand. So, what do we do here? What? Which one is it?
Isn't it f of x?
They're both really, I mean, it's just because it's linear, we don't have to worry about it. So if you actually wrote it in parentheses thinking it was a shift to the right, that's totally fine, but do you really need parentheses around it? No. So for a second there, some of you were like, ooh.
We have a lot of these problems.
But one of the things I would check with this linear, and one of the reasons I do that problem, my intercept is 5, 0 on the x-axis and 0, 5 on the y-axis. And if I go from up 1, over 1, up, what I'm really doing is making sure that the slope is 1. They didn't change the slope on us. Okay, the V-shaped graph, what did we do to it?
Right 2. Inside the absolute.
1, 2, I think it's to the right 3. 1, 2, and I think it's up 3. So if it moved to the right 3 and it's still hitting 0, 3, what kind of slope are we talking about right there?
1.
It's kind of a 1 to 1 slope, if you will. So this is going to be absolute value x, what did you say? Minus 3. That would be my opinion. It is possible because the line is so much thicker than the tick marks that if you did a 2, whatever, I'd be more accurate on the exam when I draw my graph for you, for the picture.
On the test, is there going to be like more accurate graphs?
Yeah. I mean, there won't be any confusion here.
I didn't hear.
What did we do to the S-shaped curve? Up 2? Now this is one also that it looks like it's hitting at -1, 0, doesn't it?
Sure.
Doesn't it? So, because it's up at 0, 2, and I went 1 to the left, it should only be down 1, and it kind of looks like it hits there. Looks like if you go 1 to the side and down 1, 1 to the side and up 1, it looks like I have a 1 out in front, but because it's hitting there, I'm not so sure that they have the right graph. Maybe it's like 1/3. Here's the tick mark, maybe, I don't know. So you could make an argument that there might be a number in front, but I would go with that. Again, wasn't a very accurate graph.
Yeah.
All right, what's this? Square root of x graph. Okay, so it looks like if I went over to the 1, I went up 1. If I go over 1, 2, 3, 4, I should be hitting about right there. So it doesn't look like I'm multiplying. I'm not doing a non-rigid. So this would be the square root of x. What? -1. Make sure the -1 gets under the radical and that it's not kind of hanging out where it's outside the radical and somebody might think you're right. That's it for today.